Okay, so this is the last video for these things, and then here's what I'd like to do. For question number 12, part A and B are very, very similar, because question number 12 it says factor it, and then question number 13 it says solve. So I'm going to kind of do both at once. So this is 12A and 13A at the same time. So if we have this, here's what we want to do. First, we want to factor it. And to factor it, again, I always try to look to see if there's anything I can divide out of the two numbers. And what we can divide out is a 3, which will leave us with 4x squared minus 9. Now, once you see this, you should recognize this from before, because this number can be broken up nicely, and this number can be broken up nicely. And you don't have a middle term, meaning it's 0. So if you want to think about what's going to multiply together to give you 9 and add together to give you 0, it's going to be -3 and +3. That is the answer factored. Now if you want to solve, we just want to set everything equal to 0. Well, 3 doesn't have an x, so it's really not an answer. And if you look at this, we really should only have 2 answers anyways. So our 2 answers are going to be whatever 2x minus 3 equals 0 and 2x plus 3 equals 0. Well, then I would want to add 3 to both sides, get 2x equals 3, divide by 2, and get x is equal to 3 over 2. Same thing here on this other side. And again, you're going to get your final answer as x equals -3 over 2. Okay? So that would be for a problem like this. Let's try another one. When I look at this, I go, this thing should have 3 answers. And this thing is a cube with 2 different terms. So I go, oh, I know what this is. This is an a cubed plus b cubed situation. So let's see if we can write this in an easier format. If you take the cube root of 27, which on your calculator, take 27, and you raise it to the 1/3 power, you would find that it's 3. So this thing really is 3x cubed, and this is really 4 cubed. Now, if you remember, this formula is equal to a plus b times a squared minus b a plus b squared. We would then plug all of that information in. So that would be 3x plus 4. This would be 9x squared minus 12x plus 16. Again, because a in this case is 3x, and b in this case is 4. So I just literally plugged everything in. A was 3x, b was 4. 3x squared is 9x squared. 3 times 4 is 12, and 4 squared is 16. Now what we want to do is we want to find out what makes these things equal. Well, 3x plus 4 equals 0. That's easy enough to find. We did the same kind of thing last time. And we would find that this is x equals -4 over 3. On this one, because this thing won't factor, we'll use the quadratic formula, which will be 12 plus or minus the square root of 144 minus 9 times 16 times 4 all over 18. So, if we look at this, this is going to give us a really big number inside of here. I think when we multiply all that through, 9 times 16 times 4, and then we subtract 144, we would get a negative 432. So this would be 12 plus or minus the square root of negative 432 over 18. And when we look at that, that is two imaginary answers, and there's our real answer. For this one, we'd have two imaginaries and one real. Let's do the last one. Okay, so here we go. With this, now we're going to find its factors. So if you notice on this one, we should have four answers. If I was going to factor this, this would break down to x squared plus 6, or minus 6, and x squared plus 4. Because negative 6 times 4 equals 24, and negative 6 plus 4 equals negative 2. Now again, we want to make these things equal 0. So we'll have x squared minus 6 equals 0. We'll have x squared plus 4 equals 0. And then we solve, so add 6, get x squared equals 6. Take its square root and get x equals plus or minus the square root of 6. Please remember that these are squared terms, and you should have four answers here. If you don't take the square root of both sides and you just put your answer as 6, you're wrong. We would do the same thing over here. I get x squared equals negative 4. And then I take its square root, and I get x is equal to plus or minus 2i. And please, again, remember this is going to be a 2i in this case, because it's the square root of negative 4. So the square root of a negative number means that we're going to get some imaginary numbers sitting out here. And if you check, you have 1, 2, 3, 4 answers, which should make sense. Okay, so they gave us this, and they want us to find the other solutions. So again, you can't factor this because you don't know what that factors into, but you can use this information right here to help you factor or help you solve. So we're going to use synthetic division again. Because this is x minus 2, this is not a factor. This is actually what it's equal to. So we're going to say minus 2. And then we're going to take our things down. So 1, minus 11, minus 10. And again, I draw a line down there because that's my remainder. Carry that down. I'm going to get a 1. 1 times negative 2. That gives me negative 2. This would be negative 3. Negative 2 times negative 3 would give me positive 6. That would give me negative 5. And negative 5 times negative 2 is positive 10, which would give me 0. And it is a factor, and it is a correct answer, which is good. Well then, to put that into what it really is, and again, it's always 1x lower than the number of terms you had. Again, one of our answers is x minus 2. So there's one of our answers, and this is where our other two answers should come from. This thing, try as you might, it's not going to factor, which means it's quadratic formula time. So 3 plus or minus the square root of 9 minus 4 times a times c over 2 times a, which 2 times a would give you just 2. So now we would do the rest of this, which would be 3 plus or minus the square root of 29 over 2. And again, I would leave that as my final answer. Okay, so now we're going to look for increasing and decreasing intervals. You can see that it's, whoa, that's weird. You can see on this that it's increasing right here in my greens that I'm drawing. So we're just going to label that first one. You can see this one starts at negative infinity. And it's going to go all the way up. And again, when you talk about these things, we don't use its y values because it's really hard to talk about its y values. We use its x value. So its x value it stops at is negative 0.7. And I'm just going to round that for ease. Me writing this down. Now this other one, you can see that it starts at 2.2 or 2.12. And it's going to keep going on and on and on forever, so that's infinity. Okay, so that's where it's increasing. Let's look where it's decreasing. It's decreasing right in this section right there. And that section, if you look at its x values, is between negative 0.7 and 2.2, if I could write. Because it's just that section right in there. Let's look at where it's positive. So it would be positive whenever it's above this axis. So it's in that section in red and this section in red. So if we're going to write down where it's positive, it looks like it's positive, and it starts right here and ends right there. So it's positive from 2, or negative 2, all the way to 1. And then again, it's positive again from right here all the way up. And again, we talk about its x values, so that's 3 to infinity. Let's look now where it's negative. What's negative below this axis? So it's negative from negative infinity all the way to 2, or negative 2. And then it's this little section right here, which is from 1 to 3. And that's how it would do that problem right there. First, it wants to know the possible roots of this. The possible roots of this is a lot. It's all the roots of 20. So you could say it's plus or minus 4, it's plus or minus 5, it's plus or minus 1, it's plus or minus 20, it's plus or minus 2, it's plus or minus 10. So anything that divides 20 is a possible root. And I don't think I forgot anything that you can divide 20 with. Now, that's not really that helpful, so we really want to know its actual roots. So the easiest way to find some actual roots is to have a graphing calculator and to graph it. Now you notice when it graphed it, it's a little bit off the graph, so I'm going to increase my window just a little bit just to see if I can get all the points on there. And that looks a little bit better. So now I can kind of see it's going up, it's going down. There's my graph. Now I want to find out where its actual roots are, which we call x-intercepts, which is on this line right here. If you notice, I always want to make my second function 0 so that I can find these things. There's a button right here that says calculate. I'm going to click second calculate and find some intersections. So I'm going to go down to this curve right here. I'm going to hit enter. So my first intersection is at 2. So that's one of my real roots, is at negative 2 right there. We're going to find our second one. And again, you can do this by calculating exactly or just estimating it. It looks like it's going to happen at positive 2 also, but we can double check by hitting second calculate and hitting intersect. And then we just hit enter a whole bunch of times. That would happen at 2. And let's find the last one. So we're going to trace over. This one looks like it's going to happen close to 5. Let's see. Second calculate, intersect, 5. Yeah, so those are my actual roots. And if someone asked me how I found my actual roots, well, I graphed it and I looked right there, right there, and right there. There's my actual roots. So for these problems, try them. If you get stuck with anything or any explanation doesn't make sense, please feel free to email me, and I can try to explain it in a different way. Thanks.